Hello and welcome to this tutorial. In this tutorial, we'll create a detailed mechanical drawing of the cylinder pivot in FreeCAD using TechDraw, the TechDraw workbench. Okay, so the first thing you need to do is download the files and save it in the folder where you're going to work on your practicum. You also have the FreeCAD main folder with the drawing templates, etc., as well as this DIN13 table that's also available on ClickUp. So you will download that DIN13. I'm just trying to zoom in a little bit. Anyway, so the DIN13 table will go into the FreeCAD main folder where you've got all your other FreeCAD main related files, and in the Practicum 7 folder you will have two files, the PDF showing the isometric view and section view as well as the nominal dimensions, and the FreeCAD file of the cylinder pivot. Okay, so if we open the PDF, this shows an isometric view of the cylinder pivot on the left and the section view with all the nominal dimensions on the right. Okay, so double clicking on you can either double click on the cylinder pivot FreeCAD file, or if you have FreeCAD open already, you can go to File, Open, and in the relevant folder you will find the FreeCAD file cylinder pivot 220323. Right, and there we go. So in order to open this file, it's important that you have the fasteners workbench installed on your FreeCAD installation. Okay, if that's not installed, there will be a problem. This part of the model, the M6 by 41,2 screw die, will not show correctly, which is how we've created this model. Okay, so with that done, we can start with the detailed mechanical drawing. So the first thing you do is you open the TechDraw, or you select the TechDraw workbench, and you will then insert the default page, which is hopefully set to the University of Pretoria A3 drawing template. Okay, with that done, we will go back. You will notice here at the bottom we've got the model tab and we've got the page tab. So we go back to the model tab and we select the front view so that the slot is visible. If we select the top view, if I can just drag, you can notice the slot is not visible. So you have to select the front view. That's the view we want. We want to see the slot. Alright, so with that done, you select the body, go to the page tab, and you click this icon here, insert multiple linked views of drawable objects. Okay, and the front view is now visible. And what we also want is the right view. Okay, so we can click on the right view. We can unselect this auto distribute button, and we can drag the front view slightly to the left. We also drag the right view slightly to the right. Okay, and we're happy with that. It's third angle. The scale is 1:1, same as the page. We're happy with all of that, so we can apply. And we can say okay. Now what we want to do is create a section view so that we can show, if I can just go back, we want to create a section view so that we can show the details of this threaded portion, this threaded hole. Okay, it's drilled 12 millimeters deep and it's tapped 6 millimeters deep. That's what we want to do next. Okay, so in order to do that, we select the right view, make sure it's highlighted in green, as you can see, and then we click on this icon over here, insert the section view. Okay, it doesn't matter which, well, it doesn't really matter which one you select. You can look left or you can look right. I prefer looking right because then the orientation of the section view is the same as the front view, okay, which is what I prefer. Okay, what we also want to do is type in the identifier, and we will say A. For the identifier, the scale of the section view is perfect at 1, so we can okay that. So that's section AA. Right, so let's just see. I just want to close this bottom window. Okay, so we can drag it out a little bit. Okay, and now we can start inserting the detail views. Okay, because currently, or we can insert detail views, and there are 3 areas where we will insert a detail view. The one is around this tapped hole over here. The other one is around this undercut area, and the last one is for the slot at the front. Okay, so in order to insert a detail view, you need to select the section AA, make sure it's green, and then we click on this icon over here, insert the detail view. Okay, and then there's drag highlight. Okay, click on drag highlight, and drag the view to where you want it to be. Okay, so we want it in this area over here. We're happy with that. Okay, we can just position our detail view. We want the scale to be 2 to 1. Okay, everything else is fine, so we can okay that. Okay, what I do want to do, I just want to say lock position true is active for each of the views. Okay, so the section view lock position true. Sorry, the right view is also now locked. The section view lock position true, and that detail view, I'm happy with the position, so we can just say lock position true. Alright. Okay, so that's detail view 1. Now let us select the section AA view, and we insert another detail view. We click drag highlight, we drag it. Okay, the reference is going to be 2, not 1, and we can okay that. This is detail 2. Let us put it here at the bottom. And let us make the scale also 2. And lock position is true. Okay, so the white tick in the blue circle indicates that we need to just recompute. Right, then the last detail view that we want to insert is the in this area over here. So we will select section AA again, insert detail view, drag highlight, we drag it and place it over there. The reference is now going to be 3. Okay, we can place the detail view in that area there, and we can make the scale 2, so we can okay that. Yes, we're happy with that. Okay. Alright, and now we can start with the dimensioning. Okay. Now you will notice that let us start with this view over here. Okay, so you will notice that there's no hatching. Now that's easy to fix. We can select the area and we will hatch a face using an image file, and you can change the scale if you want to. If you want to do that, you can change the scale to maybe 2. Alright, so that's the first thing we do. The second, now we will start dimensioning the sketch. Okay, so in order to do that, let us insert the center line first. Okay, so we select the applicable areas, press and hold Control. I wonder if I can. Okay, this center section, I don't know, I can't seem to select. Alright, but that's fine. Okay, so we've got those two main surfaces. We can okay that. That was the hatch. So let's now select these two surfaces again, and we say insert center line. We don't want it vertical, we want it horizontal. Extended by 3 millimeters. The weight is 0.18 and it's a dash dot. Right, we can okay that, and that's perfect. Alright. Now the other thing we want to do is, if you remember, if I can just go back, this portion of the hole is tapped, and we would like to add 2 lines to our section view or zoomed view so that we can indicate clearly that it is a tapped hole. Alright, so let me show you how we're going to do that. It's a bit of a tedious process, but basically what you do is you select this line. Nonetheless, it works, okay, and that's important and relevant as long as the method works. Okay, it's tedious the first time you do it, but later on, the more you do it, the more easily it becomes. Okay, so we select the vertical line, we click on insert a cosmetic vertex, we select point picker, and now we hover the mouse and we place it roughly in position. Okay, so we click it and we say okay. Now that point is not in the exact position where we want it, but it's more or less. What we do now is we select that vertex, press and hold Control, select this vertex, and click on add cosmetic line through 2 points. Right, and now what we do with this window is we make a note of the coordinates, especially of the second point. If you remember, this point we selected second. Okay, so I'm just grabbing a piece of paper quickly. Okay, so especially the y coordinate, this 0,244. Okay, so you can make a note of that. And the other coordinate that we want is the x coordinate of the first point. And that is minus 7,023. Okay, minus 7, and we can round it off to minus 7,0. Alright, so now we cancel it. Okay, and what we do now is we select this point and we click on this eraser, remove cosmetic object. Okay, now we repeat our process. We select the vertical line, insert the cosmetic point, and now we don't select point picker. We're going to enter the coordinates that we've dotted down here. So it's minus 7 for the x, and the y coordinate is 0,244. And we say okay, and there are now our point is in the exact location where we want, specifically in the y direction. So the line is going to be perfectly horizontal. Okay, so we click select that point, press and hold Control, select this point, and we click on this add cosmetic line through 2 points. Okay, and we can say okay. Now the default is a dashed line. So how do we change that? We select the line and we click on the pencil, change appearance of selected lines. Okay, so the weight, we want to make it a nice thick line, 0.25, and we don't want a dashed line, we want it continuous. There we go, and we can okay that. Alright, this line we can make a thin line. Alright, so if we select the line, we go to the change appearance of a selected line, we can make that 0.15 if you like, or 0.1, doesn't matter. Okay. Alright, I just want to hide the vertices, so this is what it will look like. That's perfect. And that now shows the machinist that this portion is tapped. We will obviously put in a dimension in a little bit. Okay, so if you click on this icon over here, we turn the view frames on and off. Okay, and also the vertices. Okay, so now we do exactly the same. We select the vertex, insert a cosmetic vertex, pick pointer, and we gauge it roughly, and we say okay. Now we select the vertex, press and hold Control, select this vertex, add a cosmetic line through 2 points. Alright, and now we once again make a note. We know the x coordinate will be -7, but what we are interested in is the y coordinate of this bottom point, -2,256. Okay, so we cancel that. We select this vertex, we click on the eraser or remove cosmetic object, pick the vertical line again, insert a cosmetic vertex, and we don't select point picker. We say x is -7 and y is -2,256. We okay that. We select the point, press and hold Control, select this point. We say put in a line. We're happy with that. We select the line. We go to change the appearance of the selected line. We want it continuous and we want it at 0.25. Not dashed, we want it continuous. That's perfect. So it's okay. Okay, and then we want to change the appearance of that line. Click on the pencil and we want to make the thickness 0.15. Perfect. Okay, and now we can start dimensioning. So we can say right, so let us do that. So the first thing we will dimension is the threaded or the tapped hole. So we select that vertex, press and hold Control, select that vertex, we say insert the vertical dimension, okay, and we drag it out somewhere there, that's fine. Double click the dimension and we say arbitrary text and we delete what is in there and we say M3. Okay, we will add the geometric dimension and tolerance in a bit. Alright, so next what we'll do is we want to add the depth of the hole. So we click that vertex, press and hold Control, and now I think it's this vertex over here. Sorry, we can okay that. So we select those two vertices. I'll see in a minute. Yes. Alright. Um, let me just undo that. So it's not this vertex, it's this vertex over here. That's the depth of the threaded portion. So click, press and hold Control, click, or, sorry, you can click that vertex, press and hold Control, click this vertex, click horizontal line. Okay, so let's just zoom out a little bit. And what we can do here is we can say double click the dimension. We can change the format to 1 decimal, and we can say we can add the text minimum full thread. Okay, so that indicates to the manufacturer the minimum full thread depth is 6 millimeters. If the manufacturer wants to tap it deeper, it's not a problem, but the minimum length is specified. Okay, so with that done, the only other thing that we need to indicate on this detailed view, apart from the geometric tolerance, is the depth of the drilled hole. Okay, so we click this vertex, press and hold Control, click this vertex over here. I think we click the front vertex. Okay, sorry, we just need to OK that. With those two vertices selected, we say horizontal dimension. No, it's not right. Yes, sorry, it's not right. So the depth of the hole is indicated with this vertex over here. So click that vertex, click this vertex, add a horizontal dimension. That's 12 millimeters. That's perfect. And what we will do here, place the dimension, double click the dimension, change the format to 1. Equal tolerance is fine. We'll do that, comma 2. And the over tolerance specifier for the tolerance, we click the left arrow and hit enter 1. Okay, which is perfect. Okay, that's what we want. Okay, you can also flip the arrowheads. Okay, that's also fine. Yes, I think that's fine. Okay, so we're happy with that. We can OK that. Now what I would like to do, let me just, okay. Alright, so we'll come back to the detail view to add the GD&T related to this threaded hole. Okay, maybe it's a good idea for us to now do the front view, put in the dimensions of the front view, and then we'll come back to the detail view and add the GD&T, and we'll also dimension the other detail views or zoomed in views. Okay, so alright, so okay. Right, so let's start. Okay, the first thing we want to do is let's add a center line. So we select all these surfaces and we say add a center line. Make sure you select horizontal, and you can indicate that it's a dash dot line, 3 millimeters. Extended is fine. Okay, so that's perfect. Right. We also want to indicate that this portion is tapped, so we need a line over here and over here. So let's add those two lines quickly. Now for those lines, all right. So what I want to show you, let us go. We want to know if I can just jump back. Let me just jump back quickly. So if I zoom out, okay, we know that it's an M6 thread that is machined into that portion of the cylinder pivot. Now, the distance between those two lines should correspond to the pitch diameter, okay? Or it can correspond to the pitch diameter. It's not critical. It's really a cosmetic line, but it's good practice to draw it based on the pitch circle, or pitch diameter rather. Right, so how do we get the pitch diameter? So for that we will use the this DIN 13 table. What you see here is the metric ISO threads, okay, and there are, if you go down, there are two sets of standards. The one is the normal thread, and the other one is the fine thread. Okay, so we are interested in this normal thread, so we want to go to page 496. So if you scroll down, that's a bit too much. Yes, okay, so we are now on page 496. You can see it starts with okay, we scroll down to the 10 millimeter. Apologies for the knocking sound in the back. Okay, 10 millimeters. So let's see. Okay, I'm just scrolling up. So we are interested in this outside or outer thread portion of the table, Außengewinde. And if we scroll down, okay, sorry, what we want is also the this is the pitch diameter. This Flankendurchmesser is the pitch diameter, and it gives you the max and the min. Okay, so right, so it's a bit of a calculation. Max and min, it's in this area. So if we look at a 6G, it's between 8,9. Those are the two values we have, so we can Control C that. I wonder if this will work. Let's go to Excel. No. Okay, let's see if this works. Control V. Okay, Control X. Control V. Alright, so what we can do now is just highlight those two. The average is 8,928. Okay. We can also calculate it, obviously. Plus that one equals that one divided by 2, and then equals that one divided by 2. Okay, so the radius is 4,464. Right, so with that done, let's now go back here and let us see where we want to insert the two vertices. Okay, so we select that vertical line, click Insert a Cosmetic Vertex, select Pick Pointer, and let's click on the line. Alright, so there you can see, make a note of that. It's the X coordinate is you can round it off to 35 millimeters, and the y coordinate will then be what we've just calculated here, 4,464. Right? Let's cancel that. I wonder if this is going to work. Okay, yeah, let's do this. Let's select this vertical line, click insert a cosmetic vertex, pick pointer. We want to know, yes, okay, so that x coordinate is minus 6,2. Let's just make a note of that. Alright, so let us now cancel that. Okay, let's try. Okay, so we select this point, we select this vertical line, cosmetic vertex, and now we enter minus 6,2, and I looked at the wrong dimension. It's definitely not 4,464. Sorry about that. Let me just fix that quickly. It's an M6, 6G, and it's these two dimensions over there. There we go. Now we will come right. Sorry about that. So let's just Control X, Control V. Okay, so we actually want 2,634 as a y coordinate. 2,634. Right, so let's add that. Go back to FreeCAD. Yes, so we want 2,634. Say OK, and there it is. Okay, and we might as well add the point at the bottom here. So we select the vertical line, click insert cosmetic vertex. Our x is minus 6,2, and our y is minus 2,634. Okay, so that's perfect. And now we select this vertex over here. We say insert a cosmetic vertex. The x coordinate will be 35 millimeters, and the y coordinate will be 2,634. Okay, we select this point or that vertical line, cosmetic vertex. X coordinate is 35, and the y coordinate is plus 2,634. Sorry, that was not right. Okay, it should have been minus. Okay, let's just try again. So it's 35, and it is minus 2,634. That should work now. There we go. Alright. So now we can add the vertices. So we click that line or vertex, or sorry, we can add the lines. Click this point that we've just created, press and hold Control, click that point, and we say add a cosmetic line. We can OK that. Alright, let's add the line here at the bottom as well. Okay, now we can select both those lines. Let's see if that works. Yes. Okay, we want them continuous, and we want them 1,5. It doesn't seem to be working. So we'll have to select that line separately. Okay, we want it continuous and we want it 1,5. Did it work? Oh, it's on a dash. Sorry, continuous. There we go. All right. Okay, that's perfect. Okay, that is perfect. Right, so, oh, I see. Okay, this line is now for some reason continuous and we wanted the dash dot. Cancel. No. Oh, goodness. That line, we want continuous. This line, okay, so we can carry that. This line, we don't want continuous, we want dash dot. There we go. Right, now it's right. Okay. Okay, so that's perfect. All right, so the first thing we do is we define our datum, our primary datum. And this diameter over here of this cylinder pivot is very important. And it's a nice long length. So it's an ideal candidate to define as primary datum. Okay, so alright, so we can select two vertices. We say insert a vertical dimension. It's 8 millimeters. We can scroll down. Let's just zoom out a little bit. Okay, that's fine. Right, then we double click the dimension. We are not going to add an equal tolerance. We are going to add a G6 tolerance. Right, so let me quickly go back to tolerance finder. Alright, so our basic size is 6 millimeters. This is a G6, so if we scroll down, up, here we go, there is G6. Right, so for the shaft, here we can see it's minus. Sorry, I'm wrong. This is 8 millimeters. Yes, okay, so yes, it's minus 5, minus 14. That's for the shaft. The hole is obviously not relevant. We're looking at this tolerance over here. Minus 5, minus 14. Okay, so we go to FreeCAD. We're not going to add an equal tolerance. It is, the upper tolerance is minus 5 and the lower tolerance is minus 14. Okay, the format specifier we can make 1 decimal. That's perfect. Okay, what we also want is the diameter symbol. So let me quickly open that in FreeCAD main. Okay, the diameter symbol. So we select that, Control C, go to FreeCAD, Control V. Okay, and what we also want to do in brackets, add G6. Okay, that's perfect. Okay, and then what we also want to do, right at the end, we want to add the envelope principle. We want to indicate that this diameter needs to adhere to the envelope principle. And how we indicate that is with a circled E. Okay, so now the circled E needs to be at the back here. And the only way to do that would be to add, we can okay that. Let us now add, yes, add an insert annotation. Okay. Yeah, I'm not going to do that, sorry. I am going to add it here. So just after the G6, before the tolerances, we will add the envelope principle symbol. It's not strictly speaking not correct, but it's going to be a little bit easier to interpret. Okay, alright, sorry, I'm changing my mind again. Let us insert the annotation, drag it. Okay, so default text, double or click on the arrows, highlight that. We go to our right at the bottom here, you can see envelope principle. Select it, Control C, go to FreeCAD, Control V. Here's our E, circled E. So now we just need to rotate the annotation, and how we do that. Here you can see lock position is on false, rotation is at 0. So we just rotate that 90 degrees, and then we can place it in position. And what you can even do, but I think the size is alright, 5 millimeters is alright. Alright, now it will be visible when you hide the, turn the view frames on or off. Okay, it's perfect. Okay, so that is the dimension of that portion of the shaft. Okay, and basically what the envelope principle means is that when the component is at its maximum material condition, it has to have perfect form. Okay, if you don't add the envelope principle, you will have to specify the cylindricity or the straightness of this part of the shaft. Okay, by adding a circled E, what you're saying is if under maximum material conditions, so if it's at its maximum size, which is 5 micron less than 8 millimeters, it must be perfectly straight. If it deviates from the maximum material condition, so if it goes smaller, then it can have imperfect form as well. Alright, but specifying this means we specify the straightness and cylindricity of the of that part of the pin. Okay, so that's our primary datum. So now we need to add a datum identifier, and how we do that is we select this line, insert the balloon. Okay, we double tick the balloon. The text is going to be A. The bubble shape is going to be square. The kink length is going to be 0. We can okay that. What I want to do is this dimension. Just want to see if it also has a. Okay, it doesn't have a lock position. Okay. The origin in the x direction, yes, that's close. I wonder if the x coordinate here is minus 31,985. Just making a note of that. 985. Okay, so for this, no. Okay, we'll have to eyeball it. Minus 21,5. Let's try 0.6. Yeah, 0.55. That looks good. Okay. The top value we will also then change minus 21,55. Okay. Minus 21. Yeah. Okay. That's perfect. And what we want, the end type, is we want it as a filled triangle. Okay. And we also want the end type scale to be slightly bigger because we don't want the arrow sticking out. So let's make it slightly bigger. 1,3 is fine. Okay, here we go. So that's our primary datum. We've dimensioned it and we've indicated the primary datum. Dimension, tolerance, and datum. Okay, what we also want to do now is add a surface texture or surface roughness symbol. Okay, so in order to do that, we will say, yes, it was insert symbol from an SVG file. Okay, we go to our FreeCAD main, surface finish 1,6. We open it. Okay, there it is. Okay, we want to scale it. Let's see if 0,5 will work. Recompute. Looks okay. It's still a bit big. Yeah. Okay, so what I recommend we do, let's add it. Let's make it smaller. Let's make it 0,35. Okay, recompute. Yes, that's better. That's better. That's much better. Yes, okay. Let's add it there. That will work. Okay, so we've got the surface texture or surface roughness symbol. Okay, so next, let us dimension this. Okay, this spigot over here. Okay, so in order to do that, we will, now the symbol we'll position later on. It's a bit in the way there. Press and hold Control, select those two vertices. Okay, so we do this. Double click the dimension. Okay, and this is now 5. It's also going to be a G6. So we go to our tolerance finder and we type in 5 millimeters G6 minus 4 minus 12. Okay, so we make a note of that. Double click the dimension. I'm jumping around a little bit, doesn't matter. So we take the diameter, Control C, go to FreeCAD, double click the dimension, add the diameter, Control V. The dimension itself is going to be single digit, that's fine. Not equal tolerance. Over tolerance is minus 0.004 and minus 0.012. Okay, we will add G6 in brackets and we'll okay that. Okay, this annotation, I just want to see if I can yes, I can copy, paste. Let's see if it pastes. No. No, unfortunately not. Okay, so let us add the annotation quickly. Default text, let's drag that here. Okay, we want to add the envelope principle there as well. Control C, go to FreeCAD, default text, click on the three dots, highlight, Control V, okay, and we want to rotate it through 90 degrees. Okay, and we want to put it there. Okay, let's see what it looks like if we turn off all the, that's perfect. Okay, so we want to now specify that this spigot is concentric relative to datum A to within a specified tolerance. Okay, so how we will do that is let us add a balloon. Okay, we can, there we go, let's do it there. Okay, so we are going to say, sorry, coaxial. Okay, so we select that symbol, go to FreeCAD, we add the coaxial, shift backspace. We obviously want this to be a rectangular frame. We want diameter. Control C. Go to FreeCAD. Control V. 0,02 relative to shift backspace datum A. That's what we want. Okay. Okay, so we can okay that. The balloon, we now need to change the X origin. Okay, so let's do minus 42 is too much. Minus 42,7. Minus 42 is too little. 42,5. 42,4. Zoom in a little bit. Oh, that looks good. Okay. Kink length is 5. 64. Let's just see. 64,4. I wonder if that, no, that's too much. Okay, so this, it seems as if we have to, okay, that looks pretty good. So we've got the spigot specified, concentric, tolerance, and we've got a primary data. Alright, so let me just tick that off. Okay, we also want yeah. Okay, we'll put the dimension, we'll put that symbol in a little bit. I just want to see if I can copy this. Yeah, anyway. Symbol, copy. Oh, you see, this, oh. Alright, okay, no. You can't copy it. So it's easy enough to insert it. Insert a symbol from an SVG file. Open symbol, and we used 0,35 if I remember correctly. Let's recompute it. Yes. Yo. Now we pressed for space a little bit. I'm worried that we are not going to be able to fit everything in, but let's see. Let's see. We'll improvise as we go along. Let's see. Yeah, I think it will work. Okay, so what I think we're going to do is indicate all the diameters on this view. So, except for the undercut, because we've got a zoomed in view where we can indicate the undercut diameter. But the other diameters we're going to add on this view. And then the lengths we can add in this section view. That's where we're going to add the lengths. Okay, so we'll do that. Okay. Alright. I'm gonna toggle the visibility of the frames again. Let's just zoom in a little bit. Place it nicely. Take the symbol, place it nicely. Okay. Now, what I want to do is add the this diameter. So we select the outer vertices, vertical dimension, drag it, double click. Okay. Sorry, we don't need a diameter. We're going to have arbitrary text. This is M6. Okay. And what we do want, we can okay that. Let's add a bubble. Here we go. Okay, double click the bubble, change the shape to rectangle, and we want coaxiality. Control C, go to FreeCAD, Control V, shift backslash, I guess. We want diameter. Control C, go to FreeCAD. Control V, 0,2, not 0,02, 0,2 relative to shift backslash datum A. Okay, so we can put that there. Okay, we can okay that. And now we just need to make sure what is the x coordinate. Okay, 43,8 seems too much. 43,65. Let's zoom in a little bit. Now that looks good. The y origin, let's make it 3 millimeters. That's perfect. Okay. And now all we need to do is just eyeball this. Okay, I think that's fine. That's good enough. Okay. M6, okay, so let's have a look at the view. So we've got the primary datum, surface finish, tolerance size. We've got the spigot, concentric, 0,02. We've got the threaded portion, concentric, 0,2. Okay. Alright, so let us now add the yeah. Let us now add the lengths. Let us now add the lengths. Let's see if that works. Okay. So we toggle the visibility of the frames again. Select the two vertices. Shift Control horizontal dimension. That's 2 millimeters. Okay. Double click. Equal tolerance is fine. We're going to make it plus minus comma 1. And we do for the tolerance, we also do 1. Okay, so that's the first dimension, length dimension we have. Then we want to add okay, let's see this vertex and this vertex. We want to add a horizontal dimension. Two comma 8. Okay, yeah, that's correct. That is correct. Okay, so it's 22,8 millimeters. I actually think, yeah, we won't be able to do that. This view, let's just unlock it for a little bit. What I want to do, I'm going to position false. Okay, let's move it there. And then this one, lock position false. Let's move that one there. I think it will work. Move it there. And then this one, lock position false. Okay, that's still false. Alright. Let's see if that works. Okay, so we're going to lock it now. True, true, and true. Alright. Okay, yeah, then now it's not a problem. We can shift it because what we want to do is we want to indicate that this surface needs okay, but let's first indicate the size tolerance. So it's equal tolerance, it's plus minus comma 1. The format specifier 1 decimal is perfect. The over tolerance 1 decimal is also fine. We need to we can add it here. Let's just see. Okay, that's fine. What we want to do in this view, add a bubble. Just drag it in position, double click the bubble. We want it rectangular and we want perpendicularity. So we go to our symbols, perpendicularity, Control C, go to FreeCAD, Control V, Shift backslash 0,02, Shift backslash relative to datum A. Okay, there is no kink, so we're going to do 0 for that. And needs to be perpendicular to datum. Insert a symbol from an HVG. We want a nice surface finish. Okay, so we've got that. And that as well. Okay. Right, so the next length that we want to indicate is the over tolerance specifier is 1. Okay, so that's 4 plus minus comma 2. Okay, so the y coordinate of this is minus 15,5, and we can do the y coordinate, come on, cancel, of this as well as minus 15,5. Now they are perfectly aligned. Okay, so that's what it looks like. Alright, I'm happy with that. Okay, now, so I've got the 4. Okay, so let us now add this length over here. So I'm going to toggle the visibility again. Press and hold Control, click the two vertices, add a horizontal distance. Okay, it's 41,2. That's actually wrong, right? What we actually want is this size over here, from that vertex to this vertex. We want that size, and that's 45,2. Perfect. Okay, we will set the location in a bit. We have an equal tolerance of comma 2. The 1 decimal is fine. Come on. That's fine. Okay, so we're happy with that. Let's just see y coordinate minus 48,3, and the y coordinate of this one is minus 48,3. Okay, now it's perfectly aligned. Okay, so we're happy with that. What we also want is just a reference dimension for the total length of the pin. Okay, so let's add that quickly. We can do that at the top. Just select that vertex over there, put in a horizontal distance, double click, it is 1, and to add a reference dimension we need to add it in round brackets, so that's 70 millimeters. Okay, alright, that's fine. Okay, alright, so we're happy with that. This is what the, okay, we can okay that. So this is a reference dimension, and you add that just to give the person looking at the drawing, he doesn't now have to add these dimensions to get the total length. He can see it with one glance, but there are no tolerances associated with this reference dimension. The tolerances are specified here at the bottom. Okay, so that's good. Right, so now we can go back to this. Let's just toggle the visibility again. We can go back to this view and we can specify the coaxiality of this tapped hole. Alright, so I'm going to select that, click insert the balloon, drag it, double click the balloon. Okay, we want it rectangular. Okay, we want coaxiality. Control C, go to FreeCAD, Control V, Shift backspace. We want a diameter symbol. Control C, FreeCAD, Control V, diameter. Okay, and for this hole we can specify something like 0,1, shift backslash relative to datum A. That will work. Okay, so we position it. Okay, the X location 19,95. Y needs to be something slightly bigger. Let's just get the Y right first. 1, 0,8, 0,75, 7. Okay, the X origin minus 19, minus 20. No, that's too much. Minus 19,9. Yeah, that looks good. Okay, I'm happy with that. And now we just eyeball this. There we go. Okay. Right, and what the last thing we want to do here is just add that this is detail 1. This is detail 1. Okay, so let us add an annotation. Click on the default text, the 3 arrows. We highlight the text and we say detail 1. That's fine. Okay, that you can make the text size 6 millimeters or 7. Okay, let's place it there. Detail 1. That's fine. Okay. Okay, and now it's detail view 2. Alright, so we are happy with detail 1. Let's add now the dimensions for detail view 2. First thing we... Okay, so just to explain this symmetry GD&T, because it is in line with the dimension, what we are saying is that the mid-plane of this slot needs to be symmetric to within the tolerance of 0.5 millimeters relative to datum A. That's why if the leader line of the GD&T tolerance was separated from the dimension line, it would have meant that we are referring to that face. But because it's in line, we are referring to the mid-plane of the slot. Okay, so we now need to add an annotation for detail 3 here. So let's quickly do that. Okay, if we click on default text, 3 arrows, and here we will say detail 3. Okay, and we will make the text size 7 millimeters. Right, so that's, oh goodness, yeah, let's move it a little bit. Let's just move it a little bit. There we go. Better. Yeah, that looks better. Okay. Right, so we can quickly check if we have all the dimensions. We've got the diameter, 3 major diameters. We also have the diameter of the undercut. We've got the lengths, all the lengths. We also have the chamfer dimensions or dimension, and we've got the dimensions of the threaded hole. Right, so everything looks fine. So let us now add our annotation for notes. Okay, let's just position it correctly. Click on default text, triple dot, and here we say notes, and we will say 1. Surface roughness to be RA 3,2 unless otherwise specified. To break all sharp edges to 0,3 max. Okay, by Control C, 3CAD, Control V, 45 degree, Control C, Control V, plus minus Control C, Control V, 3, Control C, Control V. Okay, so that looks right. 3 is all unspecified fillet radii to be R0,4 max, and 4 will be material, and you can just say EN24. Right. Okay, that. Okay, we can make the note maybe 6 millimeters. Let's just see how that looks. Yes. Surface roughness to be RA unless specified. Yes. Okay. Alright. There's one mistake here. Let's just see. We'll just material. Let's do this. Okay. EN24. Okay. EN24. Here we go. Or what you can do, EN24 is a specific grade of steel. So what you can also do is say or similar. EN24 or similar. Okay, here we go. Right, that's perfect. So now we will, okay, let's just move the annotation up a little bit. So we click on the title, and the title is cylinder pivot. You will add your surname, of course, or initials, drawing number you can delete. We will add your student number here. I'm not going to add my personal number, but you will add your student number as well as your discipline, mechanical or industrial. I'm mechanical, alright. Or if you like, you can just add an M. For mechanical revision, we're not going to worry about. The scale is right. Okay, so then we add the date, 2022-05-11. Okay, and then if you want to, you can also sign this, of course. LJ, and that's just to formally declare that you have done your own work. Okay, so with that done, we can have one last glance at our drawing. Everything looks right. Okay, we're happy with that, so we can save the cylinder pivot as 220511. Okay, and we can also file export PDF, and now we can call this prac 7. similar pivots on the right. Okay, and that should be all. Okay, you can quickly have a look. Yeah, and here is our drawing, everything is right. So we have to do that. There is one more